Okay, so we're going to be talking about ionic bonding in this section, section 12.2. And we want to be able to use Lewis symbols to illustrate how an ionic bond can form between monotonic cations in these following groups. So ionic bonding in everyday life, well, you probably have it in your kitchen, it's just table salt. Obviously, multiple other chemicals do this as well, but the one that's common in everyday life would just be salt, where you have a sodium atom plus a chlorine atom. And what happens is actually the sodium atom gives an electron to the chlorine atom, okay? And you get sodium chloride or table salt, okay? And so the number of positively charged sodium ions is equal to the number of negatively charged chloride ions in this crystal of salt, okay? So this crystal here, here it's shown here. Sodium ions are kind of in gray, chloride ions are in green. So the crystal is a solid with a well-defined geometric structure. That's the definition of a crystal. Okay, and so in ionic bonding, let me go back actually for a second and just explain a little bit more about what's going on. Remember in the last video, we talked about guys like sodium want to give up an electron to get a noble gas core. And guys like chlorine want to gain an electron to get a noble gas core, which is stable. And that's what's going on here. Again, the sodium, if I drew the Lewis dot diagrams here, let me do that. So that's one electron. Let me draw it in red so it's not as confusing. So red, and if you did the Lewis dot of all the valence electrons for chlorine, okay, so you can go back to our video when we were talking about this. So sodium off the periodic table, and if you wrote out the electron configuration, has one valence electron, and it's NS1. And chlorine is NS5, okay? NS2 and P5, that's what I meant, not NS5. That would be impossible because you can't have more than 2 electrons in the s orbitals, okay? That's what I meant. Okay, so these are the valence electrons for sodium and chlorine. And what happens is sodium gets rid of that valence electron and gives it to chlorine. So now chlorine has all 8, okay, around him. And again, this is what we're seeing here. This is ionic bonding. The sodium gives the electron to chlorine. Okay, and we're going to talk more about that as we go along. Okay, now to this slide. So an ionic bond, okay, their strong electrostatic forces hold oppositely charged ions in fixed positions in a crystal. And the bonds in ionic crystal are very strong, which is why nearly all ionic compounds are solids at room temperature. And these ionic compounds are poor conductors of electricity because the ions are locked in place within the crystal. But when the substance is melted or dissolved in water, the crystalline structure is also destroyed and the ions are free to move and carry with it electric current. And that's what we see here, illustrating a light bulb in some table salt versus a light bulb in some salt water. So liquid ionic compounds and water solutions of ionic compounds are good conductors, again, because the ions can move around. Okay, but that's just a definition of ionic bonding. They're these strong bonds that usually form solids at room temperatures. Okay, so we're going to talk about covalent bonds in a second, but just going back to ionic bonds, okay, before we go to the next video, I just want to make it clear that in ionic bonding, the electron is being stolen away, okay? So one of the atoms is gaining an electron and one of the atoms is losing an electron, okay? That's the real key with ionic bonding. So with covalent bonding, it's a little bit of a different story, and that's what we're going to talk about in the next video.